where we're at, we might actually be done with all this modeling stuff by the end of the week, to be honest with you. There's really only 2 more sections of modeling things to look, that we have to look at, 8, and then we're going to do 14 something or another. And then that means by Wednesday, probably by tomorrow actually, we could probably start doing, like, put all of it together. And we have this really cool review packet that we work through. So that way you can kind of figure out which one goes where, and then it's a matter of pressing the buttons and
So
figuring
quiz
it
or
out.
test by the end of the week?
Yeah. I think it'll be a test. That way it's weighted a little bit more. Plus the stuff's pretty easy. It'll probably be beneficial for many of you.
All right.
So.
To be honest, when are we getting our old one?
Didn't I get it back to you?
No.
You said Friday. Oh, I was supposed to.
I will have time today. I promise. Remind me. Logistic growth function. So a logistic growth function is a modeling set that we use for stuff that increases rather rapidly and then it tails off. So a lot of times a logistic growth one might look like this, where you have your regular XY graph, where it increases rapidly and then it tails off. So a lot of times people talk about it in the environment when you have sustaining, what is that called? Sustainability.
Yeah.
Where you can only have X amount of animals before they.
That's carrying capacity.
Carrying capacity. Thank you. That's what it was called. Thank you. So you can do stuff with carrying capacity with this, but it models out for its growth functions that levels tail off. It's like population boom. Another really cool example I thought of this morning. What is something else that people buy a lot of right away and then everybody has one? iPhones. Each time a new iPhone comes out, it takes off right away and then it tails off when everybody has it.
Not the new one.
Well, you get the idea.
No one wants that.
When it's eventually when no one wants it.
Yeah, but it tails itself through. And you're right. Some of these things will tail themselves out over time, but we're looking at it within a certain parameter. Okay. Within a specific parameter, these things are going to work through. This works really, really well for dealing with population. For a population boom.
Yeah.
So what happens here is that you get this graph that looks like this. And the point at which it's where it's changed to its maximum growth rate happens to occur at a y value that is halfway between 0 and its asymptote. Okay. Because what's going to happen is that your population is never really going to get to 0, and your population is going to approach what you guys were calling that carrying capacity. So it's going to get to that, approach towards that value. So we're able to figure out this ordered pair. This ordered pair is always going to work at the halfway point of the, if you want to call it the carrying capacity, and 0. We call this point up here C. And we're going to show you this whole formula for figuring all this stuff out. So the y coordinate here is always going to be C over 2. You're so weird. And it basically works out to be something like this. And it looks a lot worse than it is. It's going to look a lot worse than it really is. Yes. I'm going to show you what it means. You're going to be, you have to see the actual model of it. You'll be able to pull like coefficients where your actual stuff are. It's just like.
Okay, because I was thinking like the ordered pair
That y value will be whatever that c is over 2. But we're going to figure out the x value too. It all stems from being able to get out of this generic equation. So the generic equation here, guys, does not take long to get through this. Is going to be y equals some value c over 1 plus a times e to the negative r x.
Whoa.
Okay. E is the number e. Number e. Your horizontal lines at C and 0 are your asymptotes because you're never going to get to your carrying capacity. You're never going to be at 0. You have a y-intercept. You have a y-intercept here. It's always going to be at C over 1 plus A. It's going to be our y-intercept.
Wait, why only never get to the carry?
It's in a value that you're going to approach. You're getting towards it.
So what's that one equal? Like y and y equal?
So is there like a mathematical way like to describe this growth? Because it's not really exponential.
When it gets an actual problem of why this works with the population things, you'll see it. It's really, really close. It's pretty cool how this stuff works. Your domain is always going to be anything between, where the y value is going to be between, your domain is all real, your range is between 0 and C. Because it's in this wedge that you're looking at. Okay. The graphs always look like this, increasing from left to right. Always. They don't go the other direction. And the only other weird thing to find the ordered pair, this is going to be the natural log of the A value over your rate, your R value, whatever the R is. Okay. It seems like a lot of information, but remember you have a calculator and you're going to be able to figure out everything except for really this ordered pair. So of anything in there, natural log of the A value. So once you know, that's really the only thing you have to remember, is that the natural log of A over the R value is the x coordinate of your maximum growth part. That's it. A is going to be a coefficient. Okay? So your A value is the coefficient in front of E. The button on your calculator. So what happens here is that we can start with something where we have 6, y equals 6 over 1 plus 2 e to the negative, what is it, 0.5 x. From that information, you can do a rough sketch by hand. You know you have asymptotes at 6 and at 0. I know they'll be there because the rule always need to be at 0 and C. Asymptotes always at 0 and C. I also know that my y-intercept, where it's crossing the y-axis, is where? Y-axis is going to be C over 1 plus A. Well, what's my value of A in that equation? Correcto. What is 6 diviso 3? 6 divided by 3 is 2. Here's what we got. I know it's a lot to ask on Monday. So my y-intercept is 6 over 1 plus 2. It's at 2.
Wait a minute.
I also know that my maximum growth rate is going to have a y value of what? 3. I know that the y value here is going to be 3 because it's between 6 and 0. To find the a value, I just take the natural log of 2 and divide it by my r value. Now, the r value here, see how it's negative r? So what's my r value? It's just 0.5. It's just 0.5.
How was it negative
That's just the way they wrote it. Because it's being multiplied to this, and it's added to the 1. we don't really go into, I was telling third hour's asking something like that too. We don't really go into the whole proof of why all this stuff works through. I just thought it was kind of, it's actually a really cool model to work with. So if you put it in your calculator and you get your ordered pair. What is it? 3, was it 3? 386, okay. So that means your graph is doing this. Whee! That's about it. Okay. Natural log of 2 divided by 0.5. Close-ish. When you're putting it in the calculator, remember, as soon as you hit natural log, it opens a parenthesis. Close it, and then divide by. What's up now?
Can you do natural log? What is natural log 1? Oh, my son. But I put it in here and it says 0. Well, the answer is 0 then?
If it's just natural log of 1.
Yeah.
Because natural log is you undo base 10. So yeah, it has to be 0 because that just means it's.
So can A not be 1 then?
Well,
Oh,
right.
A
Yeah, I don't think A is going to be 0. I think did I skip over the rule? Yeah, you're right. Because what happens is it's going to be 0 because the rules for natural log of and it's exponential. It's the 1. 1 plus 0 is 1. 0 is 1 is 0. That's why it doesn't say that. I know that. Okay. Is that horribly scary?
No, we're not going to close out your right there.
Read what that says.
You get a y-intercept, find this point, draw the line. Now, the goofy part of this becomes when you have to solve the equation for x. This becomes like a 4-step equation. Solve that for x.
So we're gonna have to do a three-way system of equations.
No. This is just, oh wait, I gotta get, this is a graph one. Sorry, I gotta get you equal something. Here we go, sorry. I'm sorry, you're right. In this case, you would have had, you're right, I had to have it equal something. I put the wrong one up. So here, if we have 50 equals 50 over 1 plus 10 e to the negative 3x equals 40. You need to solve for x.
Right.
That'd be my first step. Isn't this fraction equal fraction?
Yes.
Yeah. Exchange-o, change-o on that diagonal. First thing to do.
Whoa.
Oh, wait, you can just do that?
Well, yeah.
I thought you had to multiply.
You could, but why?
I don't know.
Now what am I going to do?
Try and then give up.
Then subtract 1. So 5/4 is $1.25, right?
Right.
Yeah.
$1.25 minus 1 is 5. Now what do I do?
Divide by 10.
Divide by 10?
I like it.
How do you undo e?
Natural log.
Oh, natural log.
Remember, natural log undoes e.
No, that's an honest question.
And then last but not least,
Divide by -3.
divide by -3. So it's not an overly complicated concept, it's just nasty looking.
So it is overly complicated.
Not really.
It's 1.2.
I'm sorry.
Wait.
1.3.
Okay.
Oh, would you rather us keep it in that form?
I just rounded a couple decimals.
1.2.
I said it first.
1.296.
Now, to be honest with you,
8.85.
shh, guys, to be honest with you, you might be able to do all this just in the calculator.
Yeah.
Yes, sir.
Can I see the little equation then? I just need like specifically the top one. There you go for it.
If you start to think about working backwards with the order of operations, couldn't you do this in your calculator by yourself without having to write it down?
Yeah.
Try it.
Yeah, but I don't trust myself. Yes.
All right, everybody but Martine, try it. Go for it.
No.
I know how much you love using the calculator. See if you can figure that out just by calculating. You guys are calculator geniuses. Genii.
Plug it in and then see where
We're not doing electrical work.
Patrick, you're a genius.
you plug it into
Like in a lab?
You could. It's not going to be as clean. So let's see.
I got it.
Yeah.
Titanium.
Oh, that would be natural.
I got it.
Wait, got it.
Wait.
You guys like
I didn't ask.
Alright, let's see.
Is it? Wait, I got it.
Divide that up
So you
to
get
yes.
10 divided
Yeah,
by
if I said by
Can't see it from there.
Got it.
What is it? What page?
Side by negative 4.
Hey, that's happy.
Oh, that's what
Right now.
Oh, I got it. I got
Hey, Eric. Hey.
I got 0.72259293956.
I got the same.
Oh, where did the 6 from?
I just made it up.
Thanks.
I think I got it.
Hey, let me see it. I'm down.
Hey.
Hey! Oh!
Not by himself.
All right, so let me show you what this looks like via the calculator doing a model, an actual model of it. Let's do L1, L2 stuff.
Wait. Eric.
Wait.
Yeah, can you show us how to use it?
Yeah, how do you do that?
Eric, I'm not
Yeah,
gonna
can
do
you
that.
show us how to do that?
What was the equation? It was 10. All right, so
10, 9 equals 2.
all right, hold on. So in the calculator, here's what I would do. 10 divided by 9, enter. Subtract 1, enter. Divide by 2, enter. Natural log, oops, wrong button. Natural log of my answer, enter. Divided by negative 4, enter.
I didn't press enter nearly as many times as that.
Yeah.
You can type it all in at once if you want.
I think I overused my parentheses.
Why would you not want to do that?
That's fine, just write it, just do yours, write out your steps like you would normally.
This is so solid.
All right. So let's take a look at what happens when you throw a model into it with the population. Now, one of the things I'm kind of hinting at, you're going to see this a lot with populations. Okay, just so you guys remember that. Let's do an L1, L2 of populations here. L1 with years after 1950, L2 of population. This is the populations of Aurora, Colorado, years after 1950, which means we're starting at 1950, which means my y-intercept is at
1950.
That's 9,421.
Why do we son choose these places?
This would be the source from the Bureau of Census, the U.S. Department of Commerce, report of the World Almanac and Book of Facts of 2005.
Change. 64 after the
Boo. That's.
What's the joke?
Yeah. Whoa.
Here's what happens when you're looking at these models. Sometimes it's going to be difficult to see the graph. Okay. When you adjust your window, what I did for my window here is that it was going between 0, I set mine at 0 to 60, going by 10. For the y value, or excuse me, for the X values. For the Y values, I went from 10,000 to 300,000, going by 10,000s. Now, when I'm looking at my scatter plot here, it almost looks linear, but it's not. And the idea is that by remembering that when you see population growth, I want you guys to remember that that's probably going to be a logistic growth function because of the way population boom and tails out. Right? So when you go to the calculator then to figure out the actual calculations of it, we hit stat calculate. We're looking for, it actually says logistic.
Yay.
You're looking for the one that says logistic. When you hit enter, this one takes a little while to go through.
Which one? Alpha B.
Okay. In this case, B is R. Because if you look how they write out their formula. That way you're understanding where the B, why the B value is there. The B in this case is our R value in the calculator. Okay. So then I go to my Y equals, and this is where it becomes a little bit more important to be able to use a couple extra decimals when you're writing out the formula in the Y equals table. So if I use my C value, so I do an alpha, Y equals to get a fraction. 3, 1, 6, 4, 4, 1. Can I have 0.7 of a person?
Well,
Just round up to
do we
1.
count fetuses?
On the bottom here, I'm going to have 1 plus our A value, 23.5766. E. Now here I can make sure I put this in parentheses. It'll be negative 0.10256 times x. What I'm doing here is I'm putting a couple extra decimals in there because it's already there. Because now when I graph this alongside the growth model, the scatter plot, you'll see the curve of the line.
How do you fix the invalid?
What do you do for the window? I've been trying to.
My window, I set my window at 0 to 60 for x's going by 10s.
You know how that?
Your pen really didn't like you, wanted to kill you right then and there. The y min and max I went with 10,000 to 300,000, and I went by 10,000s. You're getting invalid dim still? Do you have two plots on your y equals? Yeah, turn off that second plot.
Now I'm getting error.
Minecraft is not moving.
Oh.
You had the exact same setting, however, many syntax error. It was my stat. Something wrong with the syntax. Hey.
Now do you understand? Yes. Are you gonna know your
You only did 30,000. There you go. No problem. Here, wait. Can I check your windows? Yes. I'll give you one.
Same.
No, hey, I don't move. There it is.
The Don, do a hard reset and see and retype it in and see if it works. Don't do your L1, L2, just retype the equation, see if it works. That might be what it was. Did we all get that then?
Yeah.
All right. So now let's look at the questions that they asked.
Your calculator's messed up.
Based on our regression equation, what will the population be approaching in the long run?
Get it, Matt. I'm sorry.
What's your value of C in this equation? That's where it's approaching. Your equation is approaching that value of C. Remember, C is your asymptote. The regression formula found your value of C for you. So it's approaching that, what is it, 31 something or another?
The numbers you had up there exactly, and whenever I push graph, I'm still getting an error.
So you don't have the whole thing in there.
Oh, right. That's why. Okay.
VR.
Yes.
Yeah, wait.
Okay. So then, using your formula that you have right now, could you go through your table and figure out at what year you went over 300,000 people?
60.
So now 60, that just means it's years after 1950.
Yeah, so 2010.
There you go.
So wait, what was B? What was B? I don't understand.
B?
Like, what do you mean by approaching the long run?
What is it approaching?
So what's C then? How do you find C? Oh,
Oh, it's right there! Found it!
got you. Oh, yeah, okay, yeah. I see that now, Mr. Frank. I did not get that. Thank you, Mr.
Scream close up! Oh! Oh!
Do you honestly do this in your
At least they get it.
What?
Questions?
I was thinking like this.
What?
So it's like those were
Alright, here's what I want you to do. For the parts that say do the graph and the word problem parts, when you're doing the actual regression formula, just use your calculator. These two, 31 and 32, are actually graphic, which means label your asymptotes and find that ordered pair in the middle. 36 through 42 are solved for x. And those are evens. Okay? I say 36 through 43 will be evens for solved for x. We'll go from there. Oakley dokley. I can try my best in 4 minutes, but we'll see how that works.